Hello everyone, this is Dilip. In the last video, we have seen about gradient checking and unrolling of parameters for neural networks. In today's video, let's look at random initialization and how many layers or nodes to use in each layer of neural networks. So what is random initialization? Why is this concept needed in neural networks? In logistic regression, we have seen we are initializing the values most of the time to zeros. So the parameters or the weights, we are initializing to zeros. But in neural networks, if we initialize the parameters to 0, what happens is this weight will become equal to this weight, will become equal to this weight, because since all are zeros, so this I'm talking about in the first iteration, and since all these will become equal, what happens is this activation function will become equal to this activation function. It will become equal to this activation function. So even though we are having more number of nodes in the next layer, these become useless because all of them compute to same value. Similar way, if we go for back propagation after a forward propagation, even then we get the same error result, and in the end it doesn't result in a convergence. So the goal of neural networks is we have to find some convergence point using gradient descent or similar optimization algorithms. So that's the reason we don't initialize the parameters or weights to 0 in neural networks. So what we do is, this is mostly trial and error, and after a lot of research has been done, it has been determined that a Gaussian distribution assigning the values of a Gaussian distribution to the parameters will result in better initialization. So what we do is, say for example, we take if we take 1, so we initialize the parameters between -1 and +1. Say if we choose the value of 3, we initialize between -3 and +3. So this much smaller should be more than enough. No need to go for big values. So we'll randomly initialize the weights in a Gaussian distribution. So as you know, a Gaussian distribution, we have a curve like this, where if we initialize the values, they will fall in the curve between negative epsilon and a positive epsilon. So this epsilon can be, so here it is 1 and here it is 3. Let's move on. So how many layers to use and how many nodes in each layer? Here you can see it has 2 layers in between. Let's look at the input layer first. The input layer, the number of nodes is equal to the number of variables we have. So the number of features we have, that is equal to the number of nodes in the input layer. So again, there can be other considerations like what features to consider and all, but whatever the features you finalize, that will be the number of input nodes in the input layer. And the output layer will be equal to the classifications you have. Say if you have binary classification, 1 node is enough. Other than that, if you have multi-class classification, say if you have 10 classes to identify a given input variables, so what we can do is we can have 10 nodes in the output layer, where in a matrix format they determine, say if it is 1 here, then that belongs to the first class. Then it is, if it is 1 in the second one, it belongs to second class, like that. So for input layer and output layer, the number of nodes is like we can determine based on the number of features and number of classes we want to classify. In the middle layers, how many layers to choose? So 1 is a reasonable default. Okay, you can have 1 layer and it works fine. And 2 or more than 2, like at max 4 should be good enough for any neural network. So no need to go more than that. And how many nodes you want in each layer? So here you can see there are 4 nodes in this layer, there are 4 nodes in this layer. So the number of nodes, it's always more the better, because if we have more nodes, we will have more features which will help in better classification. So the more nodes, the better, but these are computationally intensive. As you'll see in image classification problems, which we'll discuss later, the more number of nodes, we'll have something like a lot of parameters, lot of nodes. So that results in better classification. That we'll see in the later videos. So that's it for today's video. Thanks everyone for watching. Bye.